Hello all. Can you hear me?
Yes, yes, we can hear.
Okay, fine. So friends, in the previous sessions, we have discussed about the semiconductor physics, diodes and its circuits, transistors and its circuits. Now we are moving to a different domain of electronics and communication engineering, and that is communication. So it's, you can say, uh, the domain of electronics and communication branch, and it is a huge domain actually. Those students who are joining this meeting are requested to write their name into the chat box for the attendance purpose. At the end of all the sessions, we will have quiz based on whatever you have learned in all this session. So I request you to kindly refer the material which we are providing after the each sessions, or sometimes even we are providing in the advance. To refer that will be helpful to you in the quiz. You need to score 60% marks in the quiz. Quiz will be easy, don't worry much about that. It will be easy for you if you have attended all the sessions. So friends, today I will start with the introduction to communication system. Today I'll take first session, or you can say first part. Tomorrow Dr. Praveen Prajapati will introduce to the latest communication technologies, which are like mobile communication, satellite communications, and others. So within 1 or 2 minutes we will start this session. So now let us start. Today we will introduce the communication system. Okay, so what are the basic part of any communication system? Which kind of things we are using in a communication system? What are the basic component of any communication system? That today we will see. Okay, so in this lecture, I am going to cover those portions, and I hope you will enjoy this session. So, can you imagine that can we live without any communications right now? No, definitely we cannot live without any communication. Right now, whatever I am doing, I am just communicating to you through a latest application softwares which connect you anywhere in the world at instant moment. Likewise, you will have so many things which are communicating yourselves to the world at any moment, at any time, in whatever form you want to connect, you can connect. If you think that if there is no communication system in the world, then what would happen? Remember, if it has not grown like this, then you would be having this picture, which was the earlier picture of a telephonic system where if you want to connect to someone, then you will be having this kind of thing. Okay, so in initial days, there were operators which were connecting the people like this. But nowadays, you know that communication has grown to a different level, and we are just connecting with a single click anywhere in the world without in between anyone. So, internet and communication system has made it possible. Are you able to see the slides which I am moving? Just type in the chat box. I am changing, or I have changed 2 3 slides. Is it visible? Yes, fine. Okay, now what is the need of communication? So as we know that in today's world, we are located at different location and we need to communicate at any point of time to exchange the information between two parties which are separated by a distance. Let's say you are living in hostels. So you call at your home and and you ask your parents, or your parents ask you that what you have done today, what you have taken in the food today, whether you are well or not. Okay, so any means of communication if you want to do, that is called communication. Fine. So that is the need of communication, which should be done in reliable way. So what are the definitions of communication systems? Okay, so let's see some basic definitions. Communication, that means, as we have understood, that it is transferring of information from one place to another place. It should be efficient, it should be reliable, and it should be secure. That is most important. Okay, so any communication you should be using, okay, so it will be made up of sub components or subsystems which are helping you to transfer the information. So that sub components or subsystems that makes you that makes your communication system. Okay, someone wants to join. I have to exit the show once. Okay, so now electronics communication system. The initial days, what people were doing, they were having that dole and they were playing the dole, and there's some communication message were passed when initial days of the human beings. Okay, but nowadays we have electronic system. So we should have transmission, receptions, and processing information between two or more locations using electronic circuits. Okay, so which kind of information source you have? You will have analog or digital forms of information. Let's say if I'm speaking, then my speech signal, that is analog signal. Your pressure signal is analog signal. if you are having some image to be transmitted, then it is in digital form. So likewise you will have information source whether it is digital or analog. Let's say this is the brief history started from 1844 from telegraph, and we have reached nowadays to the latest communication system. This is just for your information. Okay, so this is the how it has evolved in the last years. So in the initial days, the mobiles were looking like this. You can see over here. Okay, this person is carrying a mobile over here. Okay, and headsets are connected for the communications. So it was a huge hardware, you can say, which is to be carried by a person. Okay, and it is used in the initial days. Okay, now you have two kinds of communication system. One is called analog communication system, one is called digital communication system. Students are requested to come in time. Okay, if you are coming 10 minutes late, I have to every time allow. Now again someone has come. So I have to stop my controls and again go to that Zoom meeting. Okay, so I was discussing that we have two kinds of system, analog and digital system. So what is, let us first understand what is analog and what is digital. Okay, so analog is you have the continuous variations of the signal with respect to time, then it is analog. Let's say if I take sine wave, okay, so it is continuous in time as well as continuous in amplitude. On x-axis we have time, on y-axis I have amplitude. Okay, so it can take any value of the amplitude at any time. So that is continuous in time, continuous in amplitude. Okay, while digital signals are made up of ones and zeros like this. So this is the sequence which I am drawing now. It takes certain levels, one over here, then it is 0, then again 0, then it is 1, then again 0, and so on. So it takes only ones and zeros. So that is digital signal. It is discrete in time, discrete in time, discrete in amplitude. Okay, so analog signals, they are continuous in time and continuous in amplitude. Okay, so in digital you have ones and zeros. This is a basic difference you need to understand first. Then according to analog and digital signals, we will have analog communication system and digital communication system. So in analog communication system, our source information signal, that will be analog signal. In digital communication system, we will have the information signal which is digital signal. What I mean by analog signal, that is your sine wave, your speech signals, they are your analog signal. So if your input directly is analog signal, then you have to use analog communication system, or otherwise what you need to do is you need to convert first your signal from analog to digital, and then you provide it to the digital communication system. And nowadays we are using this digital communication system. Okay, so what we do is, real world is having all these analog signal, real world is having all these analog signal. Okay, so what we do is, all these analog signal first need to convert into digital, and then we use the digital system, because it has many advantages which you can list or which are listed over here. It is inexpensive. I think I am audible, or it is voice breaking right now. Can you hear me properly or voice is breaking? Okay, now is it clear? Just type in the chat box, I am audible. Okay, fine. So let us start. Now people are coming still. Control again and again. People are Okay, so what I was saying is in digital communication system you have advantage. Why it is advantageous? Because it uses the digital signal, and nowadays we have the digital processors, digital controllers. Okay, what is the main advantage of any digital system is it can store the data, and you have the different error correction, error detection mechanism possible in the digital communication system. Why it is so? Because you have the data in terms of beats. तो अगर जीरो का वन हो गया या वन का जीरो हो गया, यू कैन डेफिनेटली करेक्ट इट, बिकॉज वन या जीरो कोई भी एक वोल्टेज का लेवल होगा. सो यू विल हैव इन इंटरमीडिएट लेवल के वन वन का लेवल +5 वोल्ट है, जीरो का जीरो जीरो के लिए 0 वोल्ट का लेवल है. अगर ओके अगर नॉइस आता है इन बिटवीन, तो अगर लेट से 5 वोल्ट की जगह पे वो 3.5 हो गया, तो हमें पता चल जाएगा कि ये वन था और ये 3.5 हुआ है, 3.5 हुआ है, and we can approximate it to 1. But in analog, you don't know what is the exact amplitude it is transmitted, because any amplitude value is possible. As I said earlier, in digital you have only two possible values of the amplitude, 0 and 1 के लिए. तो डिजिटल में उसकी वजह से नॉइस इम्यूनिटी बेटर है. दूसरा है डिजिटल में स्टोरेज आप कर सकते हो, प्रोसेसिंग फास्ट कर सकते हो. ओके, सो दैट आर द एडवांटेज ऑफ द डिजिटल कम्युनिकेशन सिस्टम. और डिजिटल कम्युनिकेशन सिस्टम के एडवांटेज की वजह से वो यूज होता है, मगर उसका डिसएडवांटेज है कि भाई सिंक्रोनाइजेशन में भी प्रॉब्लम आता है और लार्जर बैंडविड्थ वो ऑक्यूपाई करता है. ओके, मगर आप एनक्रिप्शन कर सकते हो, एरर करेक्शन कर सकते हो, you can merge the different data, the different things definitely you can do with the digital system. So nowadays we are using the digital systems, digital communication system. Over here it is CS, that means communication system. Okay, those who are coming late, write your name in the chat box. Okay, now basics. I mean, what is the basic needs of communication system? Okay, so rate of information transfer. अगर आप कोई भी communication system लेते हो तो वो कैसी होनी चाहिए? तो what we want कि भाई मेरा मोबाइल है या मेरा वीडियो कॉलिंग है, it should be fast. So rate of the information should be fast. Then whatever the signal you are transmitting, that same should be received. अगर मैंने कुछ और बोला और आपको कुछ और सुनाई दिया, then it is not reliable. So purity of the signal, जैसे ही transmit किया था वैसे ही receive होना चाहिए. Another thing is we don't want the thing complex. Okay, it should be simple. Okay, ताकि उसको build करने में भी हमें अच्छा रहे. Okay, so the system should be simple enough. Okay, so these are the things which communication system you are using. You should keep in mind of these things. Okay, now next is what is frequency and wavelength. These are the basic terms already you have studied. Just I will quickly revise. Okay, wait, someone is coming in the room. Okay, I need to admit them. Fine. So what we understand from one cycle, it is, you can say, one period of any cycle. That is I mean, it is the occurrence of repeating waves such as one positive and one negative alteration of sine wave. Frequencies, the number of cycles occurring in a 1 second. Time period, that is the time distance between a two time period between the two similar points on a periodic wave. Okay, wavelength, the distance traveled by an electromagnetic or radio wave during a one period. Now I will show you graphically so you'll understand. Okay, So over here in this graph, what you can see over here, that is this point, this point to this point, okay, that is one period, okay, so that is capital T time, okay, this to this, okay, this is called one cycle, okay, this is another cycle. So frequency is f is equals to 1 upon t, fine. Wavelength is also very simple, okay, जैसा t है वैसे ही wavelength आएगा, so it is measured in distance, so this is the lambda, okay, one for one cycle whatever distance it is traveling, we are saying it lambda. Lambda we have to measure in the distance, so its unit will be, you can say, meters, centimeters, and like that. Okay, so how to calculate the wavelength? So we know that lambda is equals to c by f, so c is equals to 3 into 10 raised to 8. Okay, so if we keep that value over here, so if you want to find the wavelength in meters, it will be 300 by f, where f is taken in megahertz. Remember, if you are using this formula, lambda is in meters and f is in megahertz. Okay, otherwise you keep it in normal form, that c is equals to 3 into 10 raised to 8 meter per second divided by the frequency, whatever value you are keeping over there. Okay, so this is very simple how you can calculate the lambda if you know the frequency. So based on the lambda, what we will have is, based on the lambda, we will have this spectrum. Okay, for different wavelength, we will have the classifications of the waves in RF or microwave based on the wavelength. Okay, so this is the classification. I need not to repeat it because you can visually see that. Okay, and let's say whatever you want to remember, you can remember from the diagram I already provided. Okay, so I will not uh, recite it again. Okay, now based on that classifications, I mean from the wavelength, okay, so if your frequency is 3 to 300 hertz, it is extremely low frequencies. Our voice frequencies will be in the range 300 to 3000 hertz. Low frequency ranges, very low frequency ranges to be have 3 kilohertz to 30 kilohertz. Low frequency range 30 kilohertz to 300 kilohertz. Medium frequency from 300 kilohertz to 3 megahertz. Okay, and high frequency from 300 megahertz to 30 megahertz. Very high frequency, if you say it is 30 megahertz to 300 megahertz. Ultra high frequency from 300 megahertz to 3 gigahertz. Super high, that is 3 gigahertz to 30 gigahertz, and extremely high, okay, 30 gigahertz to 300 gigahertz. Nowadays whatever communication we are doing, no, what we want is we want more bandwidth. Okay, so we need to move to the higher frequency range. So nowadays researchers are making the antenna, they are making the protocols which can work on this frequency bands. Okay, so nowadays what we do is we are moving to the higher frequencies to get the higher bandwidth, but the problem will come at the higher frequencies. What problem will come? देखो ये नॉर्मल रजिस्टर ट्रांजिस्टर जो हमने आपको समझाया ना, वो ये फ्रीक्वेंसीज पे काम नहीं करेंगे, क्योंकि ये फ्रीक्वेंसी पे उनका बिहेवियर टोटली चेंज हो जाता है. So we have to use the special devices on those high frequencies. Okay, so it's altogether a different subject that is called microwave engineering. Okay, so at high frequencies, definitely the behavior changes of the component, and we have to use the different components, different devices for that. Fine. So let's move to the next point. Okay. So next point says that what is spectrum? Okay. So spectrum ये word communication में बार बार आएगा. So whenever you are saying that spectrum, it means that on the y-axis you will have magnitude, or you can say sometimes it is taken power also on the y-axis. On the x-axis you will have the frequencies. So the spectrum will show you that on which frequency component or on which frequency how much amplitude or power you have available. Okay, if you know amplitude, you can calculate the power, because amplitude and powers are related with the equation that amplitude square divided by 2, that is given, that gives you the power. Okay, so rather you use the amplitude or power on the y-axis, that's fine. Okay, on the x-axis you have the frequency. So now this blue line shows that at this frequency you have this much amplitude. Now why for any electronics engineer the spectrum is important? It's very important for electronics engineer because it gives you that on which frequency components you have the which amplitude. Let's say on some frequency component I have less amplitude, so I can neglect that. So filtering, low pass filtering, high pass filterings are the you can say used in communication system. तो कहाँ पे filter कौन सी frequency पे लगाना है वो हमें उसका spectrum देख के पता चलेगा. So spectrums are very important to see whenever you are using any communication system. How the spectrums can be found? You can find the spectrum using Fourier series. You may be studying Fourier series. Those who are in standard 12, they may be studying Fourier series. Those who are in engineering, they may be studying in maths Fourier series. Okay, so Fourier series, for any periodic signal, you can find the Fourier series, which is nothing but the spectrum of any given signal. Okay, one way, that is theoretically you can find the spectrum like this. Practically how you do it, let's say I am speaking and I want to see that which components, which frequency components are available in my speech, then I have to use the spectrum analyzer. Spectrum analyzer is used to find the frequency components of any given signal. हमें just हमारा signal input में देना होगा तो उसका वो spectrum आपको वो दिखा देगा. Okay, so this is called the spectrum. Now there are two terms which are used in electronics. If I say bandwidth, the people will tell the bandwidth definition of the signal. Okay, but there is another bandwidth also in communication which is normally used, that is channel bandwidth. Okay, so first of all, if someone asks you that tell me the definition of bandwidth, then you should ask whether I should tell about signal bandwidth or whether I should tell about the channel bandwidth. Okay, so let's see one by one. So the signal bandwidth first. So if you take any signal, information signal or any signal, whatever you say, so difference between its highest frequency component and lowest frequency component of a given signal, that is the difference. That means subtraction of highest frequency minus lowest frequency will be the bandwidth of a given signal. Let's say I'm speaking something, and if my highest frequency component goes to 7 kilohertz, okay, and my lowest frequency component goes to, let's say, 20 hertz. So 7 kilohertz minus 20 hertz, so that will be the bandwidth of my speech signal. Okay, it's very simple. Highest frequency minus lowest frequency. तो कैसे पता चलेगा highest frequency, lowest frequency? From seeing the spectrum only. From seeing the spectrum only. Okay. Next, channel bandwidth. अगर कोई channel है, what is channel? I will tell you, the medium from which your signal passes, it is called channel. जैसे कि हम कुछ ट्रांसमिट करते हैं, तो लेट्स से अभी मैं बोल रहा हूँ और मेरे सामने कोई बंदा खड़ा है, तो the medium in between will be air. Okay, but if you take electrical signal, if you pass it through wire, then the wire will be your medium, so that is called channel. So what is channel bandwidth? Okay, see, if you take any channel, and if that channel that passes the highest frequency without any distortion, so that highest frequency which is passed without distortion from any channel, that frequency is called the channel bandwidth. Okay, so the channel bandwidth is the difference between the highest and lowest frequency that a channel allows to pass through it without distortion. Okay, there is no need to use the word lowest frequency over here, but somehow I have taken from somewhere, but just I am telling you that the maximum frequency or the highest frequency a channel can pass without any distortion is called the channel bandwidth. Let's say if some channel is there, okay, and if it can pass 5 kilohertz band, 5 kilohertz signal without any distortion, then its bandwidth is 5 kilohertz. Now the question comes, what happens if I allow, or sorry, if I passes 6 kilohertz signal from that channel which is having the bandwidth 5 kilohertz? So that 6 kilohertz signal will be passed. You will be getting something at the receiver, but that will be distorted one. That will be distorted one. Okay. So without any distortion, whatever is passed and you are getting, okay, the highest frequency, that is called the channel bandwidth. I think that is clear. Okay. If you have any doubt, we will cover it in the question answer session. Now the block diagram of any communication system. If you see any communication system, okay, you will have transmitter, you will have the medium, or you can say channel, okay, and you will have the receiver over here. Okay, so these are the three main parts of any communication system: transmitter, medium, and the receiver. So now whatever information source, okay, let's say you want to transmit some image, if you want to transmit some text, okay, if you want to transmit some text, if you want to transmit some image, okay, then that will be given input to the transmitter. Wait, someone is wants to come to the session. I will allow him or her. Okay, friends. So what I was talking is, yeah, where we were. Okay, yeah. So let's say in my meeting only 9 minutes are remaining. So if our meeting ends after 9 minutes, I will send you the I will send you another, I mean, meeting ID and password on the WhatsApp. So please join with that meeting ID and password after 9 minutes. Okay. So now from the information, from the information, I mean information source, or you can say whatever image takes with signal, that will be given to the transmitter. Now the transmitter passes or keeps that information onto the channel. Okay, or that is called the medium. Let's say whatever information is your speech signal, text, anything, that will be processed over here in the transmitter. तो ट्रांसमीटर में क्या क्या होगा, we will see in the detail. कि उसमें मॉड्यूलेशन होगा, एम्पलीफिकेशन होगा, ओके, और फिर उसको चैनल पे रखा जाएगा. ओके, चैनल यानी कि मीडियम. इट कैन बी एयर, it can be copper cables. In telephones we are using copper cables. You may have optical fiber cable, you may have some waveguides, or you may have some you can say some kind of coaxial cable which is behaving as a channel. So there will be channel in between. After that channel you will give that uh, the channel output to the receiver. So in receiver, whatever process you have done in the transmitter, reverse process will be done in the receiver. That means इधर से आपने जो भी इंफॉर्मेशन सिग्नल लिया था, वो इमेज था या ऑडियो सिग्नल था या टेक्स्ट था, तो उसको एक ट्रांसड्यूसर से इलेक्ट्रिकल सिग्नल में कन्वर्ट इधर हम करते थे ट्रांसमीटर में. Okay, so that should be converted back to the real time signal. So that will be done at the receiver. Another thing, you have done modulation over here, so demodulation need to be done. What is modulation? I'll explain you. Okay, if receiver signal is receiving the signal, so in between channel it may have distorted or its amplitude has been reduced. So again you need to amplify over here at the receiver. So there will be amplifiers at the receivers also. Okay, so now let's just understand the things in one by one. Okay, so communication system, first portion is your information which is to be passed, or your information signal. Okay, so the message which you want to pass, it can be audio, video or text as I said. Okay, second is transmitter. So transmitter में पहली चीज आती है, that is you need to convert your signals to the electrical signal first. So you need the transducers. Okay, after transducers you need to have modulation. Why modulation is needed I'll cover. Then you will have some mixture or translators. Okay, you may have some amplification, and then it is, if it is wireless communication, you need to give it to the antenna. If it is non-wireless, you will directly put onto the channel. Okay, so transducer is used in you can say transmitter, which converts any physical quantity to electrical, because we are working on electrical signal. So first transducers need to convert it to the electrical signal, and then we are giving for the modulation, because modulations can be done on the electrical signals only. So the example is given over here. The speech waves are converted to the voltage variations by a microphone. The microphone converts your speech signal into the electrical one, and then it passes to the modulations or mixers or other functions, amplification. Then next comes is your channel. Okay, so medium that bridges the distance between source to the destination. Okay, it can be free air, it can be coaxial cable, it can be fiber optics, it can be waveguide. Each one will have its own advantages, disadvantages. Now there is latest technologies which are used in USA and other developed countries is called fiber to home, where the fiber cable is used, okay, between transmitter and receiver. Okay, the fiber cable will have very good bandwidth, you will have less noise and other advantages, but it is costlier. In India we cannot afford that. Okay, but still some private companies like Reliance Jio, they are laying the fibers, so soon you will have the fiber communication at your home. Okay, so if you are using air, then what you will have is you will have some noise distortions which is added with the signal. Okay, if you are using some covered medium, then you will have less distortion, less noise. Receiver. So whatever is kept onto the channel, it will be received by the receiver. If you are having wireless system, then you need antenna to receive. If it is normal wire channel, then what you will have is simple wire which from which it will be taking the signal. Okay, after taking the signal, what we need to do is जैसा ट्रांसमिट किया था इंफॉर्मेशन सिग्नल वैसा हमें वापस लाना है. So we need to recover the message signal into the receiver side. Okay, so it should be converted into the form which is suitable for the output transducer. Okay, जैसे इनपुट में हमने क्या किया था कि स्पीच सिग्नल को इलेक्ट्रिकल में कन्वर्ट किया था, वैसे ही जब आप सुनना चाहते हो तो इलेक्ट्रिकल तो सुन नहीं सकते, तो उसलिए कुछ ट्रांसड्यूसर रिसीवर साइड भी चाहिए. तो रिसीवर साइड हम क्या करेंगे, इलेक्ट्रिकल टू voice should be converted, so speaker kind of thing is needed for the speech communications. Okay, other things which are performed at the receivers are like demodulation, filtering, amplifications. Okay, so that you can receive whatever has been transmitted. What is our goal in communication system? जो ट्रांसमिट किया था वो रिसीव होना चाहिए, जो ट्रांसमिट किया था वो रिसीव होना चाहिए. Okay, so transducers are also used at the receiver. Now what is modulation? Okay, modulation is a let's say someone wants to come. Okay, people are there in the fine. Now what is modulation? So modulation is a process of changing one or more property of an analog carrier in proportion to the information signal. Okay, if you take any analog signal, okay, what you will have is you will have amplitude, you will have frequency, and you will have phase. So based on that, you can change that property according to the information signal, and then you can have the modulation based on that. So these are the analog modulations. Okay, I will tell you other types of modulations are also available. Okay, but right now whatever I am talking, they are called analog modulations. Okay, now what is the need of modulation? क्यों modulation use करते हैं? 12 में भी ये आता है. Okay, for ease of the radiation and reductions of the antenna size. Let's say if you don't use the modulation, then your antenna size, which will be impractical. Let's say if you want to transmit from one place to another place which is far away, then you need very high size of antenna. Okay, and which is practically not possible. So what we are doing is we are using the antenna. Okay, but if we are using the modulating frequency which is high, then antenna size depends on the modulating frequency. That is, antenna size will be normally lambda by 10 approximately. Okay, so lambda is the wavelength of the carrier signal. Okay, so your carrier signal, that will be, you can say, which will be of in few megahertz or hundreds of megahertz. So your practical antenna will be coming to the few meters. Okay, now another advantage is if you use the modulation, okay, the effect of noise and interference, that will be less, because see, you are moving completely to the new frequencies in megahertz, or you can say different carrier frequencies are used. If you are using only baseband, that means हमारा जो स्पीच सिग्नल है वैसे ही मैं ट्रांसमिट कर दूं, तो आप भी वो फ्रीक्वेंसी में स्पीक करते होंगे, मैं भी वो फ्रीक्वेंसी यूज करता हूँ, तो वो इंटरफियर हो जाता है. मगर मैं क्या करूंगा, मेरा जो है वो अलग फ्रीक्वेंसी पे, आपका अलग फ्रीक्वेंसी पे. लेस देन 1 minute is remaining in the meeting. Okay, meeting will be stopped at any time. We will move to the next meeting ID again. Okay, so reductions of noise and interference. Another thing is you can assign the different frequencies, as I can say that you can assign the different frequencies and you will have the multiplexing. So you can transmit multiple signal if you use the modulation. Okay, if you can transmit the multiple signals at a time, that is called multiplexing. Okay, so you will have so many signal transmitted at a time with the use of the you can say multiplexing techniques. Okay, we can increase the speed of the transmission. So these are the advantages of modulations. Another, let's say, topic which we are going to discuss, that is type of the modulation, analog modulations and